Hello dear students, so welcome to Bhauta Vijnana YouTube channel. So in this video we are going to derive a very important relation between Cp and Cv using the first law of thermodynamics. ಅಂದ್ರೆ ಈ ವಿಡಿಯೋದಲ್ಲಿ ನಾವು ಫಸ್ಟ್ ಲಾ ಆಫ್ ಥರ್ಮೋಡೈನಮಿಕ್ಸ್ ಅನ್ನು ಯೂಸ್ ಮಾಡ್ಕೊಂಡು ಮೋಲಾರ್ ಸ್ಪೆಸಿಫಿಕ್ ಹೀಟ್ ಕೆಪಾಸಿಟಿ at ಕಾನ್ಸ್ಟೆಂಟ್ ಪ್ರೆಷರ್ ಮತ್ತು ಕಾನ್ಸ್ಟೆಂಟ್ ವಾಲ್ಯೂಮ್ ನ ರಿಲೇಶನ್ ಅನ್ನು ನಾವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋಣ. ಸೊ ದ ಡೆರಿವೇಶನ್ ಇಸ್ ಇಂಪಾರ್ಟೆಂಟ್ ಫಾರ್ 5 marks. So let us start. Cp minus Cv is equal to R. Okay, to derive this one, let us first consider using the first law of thermodynamics. So mathematically first ಬರೀಬೇಕು using the first law of thermodynamics. According to first law of thermodynamics, so mathematically we write the amount of heat supplied, say delta Q is equal to change in internal energy of the system and work is done by the system, say P into delta V. Illi word annu pressure into change in volume agutte. So where these symbols have their usual meanings, delta Q indicates the change in amount of heat given to the system, delta U indicates the change in internal energy, P is the pressure and delta V is the change in volume of the gas. Okay, so let us call this is equation number 1. Now the molar specific heat capacity at constant pressure. Now first so molar specific heat capacity at constant volume ಅನ್ನು ಫಸ್ಟ್ ಡಿಫೈನ್ ಮಾಡೋಣ. at constant volume. So constant volume means say V is constant. According to the definition, so this is the Cv equal to, so for 1 mole of ideal gas means we can take the amount of substance is 1 mole. Therefore directly we write amount of heat supplied to change the unit temperature at constant volume. So this is the value. Now you can substitute or you can find out delta Q by delta T from equation 1. Okay, using first law of thermodynamics we can write it is delta Q. So as volume is constant, so volume is constant means we write the change in volume is 0. Change in volume ನಮಗೆ ಏನಾಗುತ್ತೆ 0 ಆಗುತ್ತೆ. So therefore we write it is delta U by delta T. So at constant volume and this term gets 0. So we can prove that Cv is equal to delta U by delta T. So you call it is equation number set 2. So here we drop the subscript V. Now subscript V ಅನ್ನಲ್ಲಿ ಡ್ರಾಪ್ ಮಾಡಿದೆವು. ಯಾಕಂದ್ರೆ ಕಾನ್ಸ್ಟೆಂಟ್ ವಾಲ್ಯೂಮ್ ಇದ್ದಾಗ ಇಂಟರ್ನಲ್ ಎನರ್ಜಿ ಆಫ್ ದ ಐಡಿಯಲ್ ಗ್ಯಾಸ್ ನಮ್ಮ ಟೆಂಪರೇಚರ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗುತ್ತೆ. Therefore so we avoid this V subscript and now the molar specific heat capacity at molar specific heat capacity at constant pressure ಅನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿ. ಸೊ ಕಾನ್ಸ್ಟೆಂಟ್ ಪ್ರೆಷರ್ ಇದ್ದಾಗ ಸೊ ಆಸ್ P is constant. Now again by going to the basic definition, say Cp equal to delta Q by delta T for 1 mole of an ideal gas. So at constant pressure. Now according to the first law of thermodynamics, delta Q by delta T means, so again how much the heat energy changes per unit temperature? This is the change in internal energy of the system per delta T. So at constant pressure plus P is constant, so we write it is delta V by delta T. So at constant pressure. Now the equation can also be expressed as Cp is equal to delta U by delta T. So here again I will neglect this subscript P because the change in internal energy only depends upon the temperature for an ideal gas. So ideal gas ಗೆ ಇದು ನಾವು P ಅನ್ನು ನೆಗ್ಲೆಕ್ಟ್ ಮಾಡಬಹುದು. ದೆನ್ ದಿಸ್ P ಸಬ್ಸ್ಕ್ರಿಪ್ಟ್ P ಅನ್ನು ಮಾತ್ರ ದೆನ್ P into delta V by delta T ಆಗುತ್ತೆ. So this is at constant pressure. You can call this is equation number 3. Now consider 1 mole of ideal gas. Okay, now consider say 1 mole of ideal gas. Okay, for this 1 mole of ideal gas we write, so ideal gas equation, pressure volume is equal to R into T. So where P is the pressure, V is the volume, R is the universal gas constant and T is the temperature. So now at constant pressure I will find out at constant pressure constant ಆಗಿದ್ದಾಗ so P equal to the change in volume equal to R into the change in temperature. So this change in volume, here it takes the change in volume and the right side take the change in temperature. Therefore by cross multiplication as constant pressure. So P into delta V by delta T. So again at constant pressure, which is equal to R. Now you can substitute in equation 3. Okay, now you can substitute in equation 3. When you substituted this value, say from equation 2 and 3, from equation 2 and this value, both are substituted in 3 means, so equation 3 implies, we can write, so this is the value of Cp and delta U by delta T, we can directly write as in Cv from the equation 2. Equation 2 ನಿಂದ ಇದನ್ನು ನಾವು ಡೈರೆಕ್ಟ್ ಆಗಿ Cv ಅಂತ ಬರೀಬಹುದು, then plus of P into delta V by delta T at constant pressure, we have proved that this is the R value. Therefore, we write Cp minus Cv equal to R, a most important derivation. So this proves the value of molar specific heat capacity at constant pressure is always more than the volume. Why it is always more than the volume means, because when the ideal gases are heated at a constant pressure, so this amount of energy is partially utilized to change the internal energy of the system, and as well as the volume of the gas is also get expands. Due to that reason, the molar specific heat capacity at constant pressure is more than the volume. But in case of the CV, ಇಲ್ಲಿ ನೀವು CV ನೋಡಿದಾಗ ಇಲ್ಲಿ ಗ್ಯಾಸ್ ವಾಲ್ಯೂಮ್ ಎಕ್ಸ್ಪ್ಯಾಂಡ್ ಆಗೋದಿಲ್ಲ, because the volume is held constant. ವಾಲ್ಯೂಮ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಇದ್ದಾಗ, so change in internal energy only, so this temperature is, or this amount of heat energy is utilizes only to change the internal energy of the system. Therefore, always Cp is more than the Cv. A very important relation for the 5 marks. So better you practice well. So we'll get an idea how to solve the relation between Cp and Cv. The main theme is, the main principle is using the first law of thermodynamics. Okay, thank you.